Number 3 is where I'm going. Let's go there together, please. Okay, so getting into the examples. Consider y equals sine x at x equals pi over 3. Now, based on that, it says we know, okay, I'm thinking, but do we? We know the ordered pair corresponding to this angle is 1/2 comma square root of 3 over 2.
Cosine sine.
Right? Because this is the cosine of pi over 3, and this is going to be the sine of pi over 3, right? Because an ordered pair is always cosine sine. So if you remember that unit circle that I gave to you as a junior?
Mm-hmm.
Those ordered pairs were all around the edges, right? Okay, so, okay. Since the angle pi over 3 is approximately 1.04 yada yada, let's write the linear approximation for 1.05. So, excuse me, with this in mind, okay, looking at what we were looking at on the other page, remembering our linear approximation, which is what I want to start with, f of a plus f prime of a, nope, gosh darn it, times x minus a. Okay? Now, with that in mind, we're going to use 1.05, right? Okay. So A is our, well, what do I want to say there? Oh, linear approximation 4. Okay, sorry, my brain's having a pause. Got it. Lunch has thrown me off here now.
Yeah. Halftime.
Got to get my brain back in the groove, you know. Okay, so with this in mind, we're going to plug in 1.05. To find the approximation, we've got to write our equation first. That's where I was struggling for a moment. So, to write our equation, we were given the ordered pair, yes.
Mm-hmm.
What do we also need besides an ordered pair? A slope. How are we going to find the slope? The derivative. What do we need to take the derivative of? Sine, right? If the given function is sine, what is y prime? Cosine x. And so then we want to find evaluated at pi over 3. What is cosine of pi over 3? 1/2. Okay, so let's write our form, or write our function, is what I want to say here. So f of a is going to be
Square root of 2.
square root of 3 over 2, plus f prime of a is going to be 1/2. For the moment, x minus a, so x minus
Pi over 3. Pi over 3. Right? X minus a. Square root of 3. No, not square root of 3. Pi over 3. Not pi over 3? I don't know what it is.
I'm processing for a moment.
Oh, okay.
It's 1/2 because it's this right here.
Oh, because that's a.
Because we have a 1/2 that is our slope. And we have our, when we talk about this point being an xy point, it's also the idea of it's a comma f of a. Yes? Sorry, you guys, I'm like, well, oh wait, or? No.
I know that. Also, it's freezing in here.
Really cold and chilly. Okay. pause. Why am I so confused? Okay. Just strike me wrong. Strike me wrong.
Wrong.
You guys were right.
Actually,
Yeah.
wait, what is it?
To be fair, I didn't
That's
say
so
an
crazy.
answer.
So I'm gonna guess the A minus A comma
Where
X
is
A is like not necessary.
Oh. Okay, that's not what I was trying to erase. I'm trying to erase the 1/2. And I'm like, why is it not erasing? Oh my gosh. I wrote a bunch of stuff in there in between that I didn't remember.
I just want the day to go.
I agree.
I spoke to
Okay. Sorry.
I had a smoke break.
I really did.
Why is it higher? That's not something
They don't work.
Okay. The given x value we were given was pi over 3. Okay? Thus the reason we want to use that, or the problem is considering it at pi over 3.
Oh.
And that's what we're looking at there. We use pi over 3 to find the slope. Our y value, though, has to come from the ordered pair. Or actually, the y value, well, it's going to be sine of pi over 3. And sine of pi over 3 is square root of 3 over 2. My apologies. I'm allowed confusion on occasion, right? Oof. I don't know. Okay. Now, there's our equation. What were we supposed to be doing here?
Finding the
Linear
linear approximation.
approximation for 1.05, yes? So now we are plugging the 1.05 in there. So it's the idea of f of 1.05, which is L of 1.05. And yeah, I have a decimal answer, so I must have just gone calculator here.
Such a good.
So which, when you have the pi over 1.05 minus pi over 3, you're going to have to go calculator there.
The entirety?
Are we getting it? Are we trying it? No.
Now I guess I will. Where's the pi? Oh, there. Okay.
Sure.
I did not think right.
One,
Am
eight,
I
six,
about
seven,
the same
What'd you
Two,
say?
six,
0.8674.
What do you
I should have just let you say.
1.867.
Okay, I thought y'all said 2.674.
No.
It goes on from there, but, Okay.
And then we needed this bottom.
For A, that's all we had to do.
Nice. Yeah, I was combining two.
Okay. For B, they're asking us to find the
Error.
error of the approximation.
So minus cos over graph. No.
Not percent of error.
We have
Oh.
wait.
Oh, the equation.
Not percent of error.
It was like you subtract the.
So this is, if you're looking at the previous page, this is item number 5. When finding the error or accuracy of an approximation, use your calculator. Find the absolute value of the difference between the exact amount and your approximation. Then the error should be stated as being less than 10 times, or 10 to some negative whatever power. Okay. So we're taking the original, so the original f at pi over 3 minus what we found, which is the linear approximation at 1.05.
That's all we have to do.
Well, you have to do the math, but
Yeah.
now, if you've done this on the calculator, you have this number right here, yes? You have this 0.86 number, 867 number in your calculator. I would just, even if you've cleared it, you can still arrow back up to it. Now, for f of pi over 3, what's that mean we're doing? No, not 1.05, but the precise, oh, wait. No, because we're doing, gosh darn it. It is the 1.05. I give up. This is not my day.
If you are in group 4, if you're in group 4, or you have not gone today to Tipton to the career fair,
That's just bad.
which is 8th grade through 12th grade, please come to the middle school bus entrance.
I haven't gone. This is Sergeant.
I
go.
No. You guys are stuck.
We only have
That was really lucky.
Okay. Sorry, it's the error of the approximation. So, of course, yes, we have to plug the same number in both places. So we're plugging in the 1.05 into the original minus the approximation we got. So when we say 1.05 into the original, you're doing sine of 1.05 minus that lovely decimal we got earlier. Why is this not coming up to the right answer according to my notes?
Is it meant to be negative?
It is meant to be negative, but
e to the negative 6.
Negative 3.0.
I got a negative answer. Well, it's not negative, but it's. What? Never mind.
No, it's not.
-3.
Okay, you round it. Don't round.
okay, what have we done wrong? Why is this such a struggle for me
Are
today?
we supposed to plug in since the angle of pi over 3?
No. I don't know, maybe I'll try. I don't know what my deal is. Nope, that doesn't help. I didn't think it would, but I'm in radians. As you guys, because I'm that negative 3.4, I'm getting that same thing, but in my answer key, I have written negative 2.77. Why? What am I doing wrong? I can't believe I'm struggling with the ideas. I don't think my answer key would have been wrong last year, and I totally didn't, catch it. Okay, so that number's that right there. Unless I don't know. Okay, we're going to go with what we're getting because it's still going to give us the same error answer, which is based on the number of zeros. So, if I'm correct, you guys are getting negative 3 point, this number, right? 402,60598, you're getting that? But then it's times what?
10 to the negative 6.
10 to the negative 6. Now, what does that look like as a real number? Because we need to know how many zeros there are. You take the decimal and move it where?
6 to the left.
6 to the left. So this is really going to be negative 0 point. How many zeros am I going to have here? 5, because then the sixth one is the 3. Okay. I'm not going to write all of that. So the idea is your calculator is going to give us scientific notation. I don't know why I have negative 2.77 times 10 to the negative 6. I really can't figure out what I'm doing astray there, but so now when we talk, if you go back and look at the previous page on number 5, it talks about air being less than 10 to the negative. How many zeros do we have in the result? This is 5 zeros, yes?
Yeah.
So we're going to report our error. To be less than 10 to the negative 5th. That is totally based on the number of zeros. Still not sure why this doesn't match up with my answer key, and it's really frustrating.
What is your answer?
It's at negative 2.77 times 10 to the negative 6. Now, here's the deal. It's still 5 zeros. So am I still getting the same error answer?
Mm-hmm.
Which is why I just went with it, because it's...
Could your calculator in degrees last year?
I don't know. I'm going to circle that. I'm going to look at next period, because I don't understand why I'm off. Okay. So that is really small error, yes? Okay, really small error because it's within, you know, when I have something that's after the decimal spot, there's 5 zeros and it's a 6th spot, that's going to be very little error. Okay, I'm sorry about the confusion. Questions?
All right. I forgive you.
Whew. Okay, shall we try number 2? Number 4. Sorry, that was number 3. Number 4? Here we go.
Yes.
Okay. Little lovely calculator symbol on all of these, right?
Yes.
As you can see, we needed the calculator on the last one. Okay, find a linear approximation to y equals 2 to the x at x equals 3. Use the tangent line to estimate x equals 2.97. Okay, so basically same thing we did last time. Write the equation, and then we're going to plug in 2.97. Let's see if I can do better this time. Okay, we are going to have slope, yes. The derivative of a number raised to the power of x. This is one we're supposed to know. Okay, you can write it as 2 to the x times natural log of 2, which is what I have particularly written here, or natural log of 2. Did we write it as a time natural log of 2 times 2 to the x? Either or.
I had 2 over x.
No, that's a problem. That would be,
That's the
even then it's not exactly.
Derivative of the natural log.
Derivative of natural log is 1 over x.
Yeah.
Yeah.
So-
I had 2 over x.
Yeah, I don't know. You're making up your own stuff here. Okay, now we're going to have to do the slope. We're going to need to evaluate this at 3. So 2 to the 3rd natural log of 2. About the only thing you can clean up there is 2 to the 3rd is 8. And so I would just leave it as 8 natural log of 2. Will we put it in the calculator later? Yes. But I would, for right now, leave it as this because you don't want to have to write all the decimals. Okay? We know a slope. What else are we going to have to know that I just realized we don't know? We know an x and a y, right? What's the x? 3. So we need to know f of 3?
8.
Fair enough?
Mm-hmm.
Okay, let's write our linear approximation. You guys want to put the 8 out front or you want to put it out back?
Front.
Okay, keep it in the front. So this is your, basically your y value, right? Plus, what do I need? Your slope. 8 natural log of 2 times
X minus 3.
x minus 3, because we're trying to write our linear approximation, yes? Now, in all honesty, leave it like that. Okay, so there is our linear approximation. What do we have to do now?
Plug in 2.9.
So now we're using it to estimate 2.97. So 8 plus 8 natural log of 2 times 2.97 minus 3. I could do 2.97 minus 3 in my head, but that's about as far as I'm going to get in my head. So I would say, go for the calculator.
Doug.
Yeah.
We match my answer key. You know how happy that makes me.
A lot.
I'm sorry, I'm frustrated with myself today.
It's just a
At least you're communicating.
I'm communicating, I am
Let's find the
frustrated.
right side, guys.
I'm being honest with you, okay? So I'm going to say, I'm going to throw in those dots. Therefore, f of 2.97 is approximately equal to L of 2.97, which is the 7.8336 or 8334, however you want to do it. Minimal how many decimal places? 3. Unless told specifically otherwise, minimal 3. Okay.
I threw a lot more today than I thought we would.
And 5 is going to have to wait for Monday.
Let's give it a little bit of time.
Oh, what do we have? 5, 6, and 7?
You're actually making decent.
Oh, wait, and 8, 9.
Since we have a little bit of time, can we
Maybe Monday we want to eat.
practice on this one doing the air?